It is 2014 structured essay problem. The following measuring instruments are given to determine the density of a material of a small uniform cylindrical container of the form shown in figure. Part 1, a vernier caliper. Part 2, an electronic balance. Part A, before using the vernier caliper for taking measurements, what is the first step that you should take? We can write, we have to consider zeroth error. And if there is a zeroth error, we have to calculate it before using instrument. Part B, write down an expression for the density D of the material of the container in terms of volume of material V and its mass M. Density equals mass over volume. Then part C, in addition to two measurements in outer diameter and inner diameter of the container, state other measurements you would take using the vernier caliper to determine the volume of material. We can write zeroth error is another measurement. Then depth of the container and external height of the container. Part D, the figure 1 to 5 below shows the relevant positions of the main and vernier scale to one set of measurements that has been taken in order to determine the volume of the material of the container. Relevant jaws, depth, rod that have been used to take each measurements are shown on the right hand side of the figure. In left hand side they have given reading corresponding scales. Right hand side they have given corresponding parts of the instrument. Identify the figure correctly and relate them to measurement that have been indicated in C and fill in the table below. When filling the table, we have to write value correctly. We can write answer without calculating. Reading of the vernier caliper in first one, you can identify second part of the vernier scale division is coinciding with main scale part, and main scale reading is 0. Then 0 plus 0.1 into, I will use millimeters 2. Then it is 0.2 millimeters, but they have given in centimeter answer. Now I will write it without converting centimeters. I will write all values in millimeters. Then second one, for that part, middle column is blank. Then last one, zeroth error. Corresponding reading is zeroth error. We have to write corrected reading for the second column, but there is no corrected reading because of it is zeroth error. It is not a reading. Then second part, main scale reading you can identify 2 plus 0.1 into coincided part is 2. Then there is a problem. In this one, main scale reading 20 millimeters, 2 centimeters is 20 millimeters. Then it is 20.2. We have to subtract this reading. Then we can obtain 20 millimeters. And you can identify external jaws are used. Therefore, it should be outer diameter or height, but height should be the greater value, you can identify fifth part is the greater value. Therefore, this one should be outer diameter. Then third one, main scale reading 16 plus 0.1 into coincided part again 2. It is 16.2 millimeters. We have to subtract this 0th error, then 16 millimeters. When writing corrected reading, we can use corresponding decimal places, because of we have to show that the least count of the instrument is 0 millimeters, 0.1 millimeters. Then for the third part, they have used internal jaws, therefore it should be inner diameter. They have given outer diameter as x1, inner diameter as x2. Then next reading, fourth part, main scale reading 30 millimeters, 30 plus 0.1 into coincided part again 2. It is 30.2 millimeters. Then corrected reading 30 millimeters, 30.0 millimeters. And it is the measurement obtained by using depth bar. Therefore, it should be depth of the cylinder, and they have given it is as x3. Finally, part 5. Main scale reading is 35 millimeters plus 0.1 into corresponding coincided part is 4. It is 35.4 millimeters. Corrected reading is 35.2 millimeters. It should be height of the cylinder. They have given it as x4. Now you can compare this outer diameter and height. Height is the larger one. Therefore, we can't write the outer diameter for this one and height for this one. We have to write in this method. In part E1, write down an expression for the volume V of the material that contain the symbols x1, x2, x3, x4 in the given table above. Now there are two cylinders, large cylinder and small cylinder. We can write volume of large cylinder phi r squared h. Phi, when getting radius, we know that outer diameter is x1. Then large radius x1 over 2 squared, and outer height is x4. Phi r squared h. Then we can write volume of a small cylinder. Phi diameter, inner diameter x2. x2 divided by 2 is inner radius squared, and depth is x3. Then we can write volume. We have to subtract this one and this one. Phi is common, 2 squared, 4 common. Then we can write x1 squared, x4 minus x2 squared, x3. It is answer for E, part 1. Then part 2, using the expression written in part E and above readings that you have given in the table D, calculate V. Take phi value as 3. Then we can substitute values. V equals 5 value 3 over 4 x1 squared. x1 means this one 20 squared. Multiply by x4. x4 is 35.2. When calculating we have to use corrected values, not readings. x2 is this one 16 squared. x3 is 30. It is in cubic millimeters. Then I will convert it to cubic meters. When converting millimeters to meters, we have to put 10 to the power minus 3. Then there is a third power, therefore we have to use 10 to the power minus 9. Then you can simplify it. 3 over 4, 20 squared 400 multiplied by 35.2 minus 16 squared 256 into 30 into 10 to the power minus 9. Then we can multiply 3 over 4. There are two zeros. 4 into 2 8. 4 into 5 20. 2 remaining. 4 into 3 12 plus 2 14. There is only one decimal place. We can remove one zero. Minus, there is only one zero for 30. 3 into 6 18. 1 remaining. 3 into 5 15 plus 1 16. 1 remaining. 3 into 2 6 plus 1 7. Multiply by 10 to the power minus 9. 3 over 4 multiplied by 0 minus 0 0. 8 minus 8 0. 10 minus 6 4. 13 minus 7 6. Into 10 to the power minus 9. Divide by 4 1. 16 0 0. 3 into 16 48. 4.8 into 10 to the power minus 6 cubic meters. In part F, according to the readings of electronic balance, if the mass of the container is 9.6 grams, find the density of the material of the container and give your answer in kilogram per cubic meter. Right. Then we can use density equation. Density equals, it is part F. Density equals mass divided by volume. Mass is given as 9.6 grams. When converting grams to kilograms, we have to put 10 to the power minus 3. Volume is this one. 4.8 into 10 to the power minus 6. We can cancel out 10 to the power values. 10 to the power minus 3. This one is 2 times of this one. Then we can get 2000 kilogram per cubic meter is the density.